Good morning. My name is Tasos and I'm from RF Elements. Thank you for joining us this morning. I'll be doing a presentation on our symmetrical sector antennas. So let's start with a little background here. RF Elements is based in Slovakia in Europe, the European Union. We were established in 2010 and currently have over 50 employees worldwide. We have offices in Hong Kong, which is our distribution center. Our headquarters is in Bratislava, which is the capital of Slovakia. And we have a logistics office in Humene, which is a small town in East Slovakia. And then my office here in Texas. Our main focus is basically innovation and really unique products for the wireless world. So here are our symmetrical sectors. Some of you have maybe seen these before at Wispapalooza or some other trade shows. They are the conical horn antennas with our Twistport technology. So what is a symmetrical sector? As we know, traditional sectors that are used are kind of these long and narrow sectors that usually have a much flatter beam than a symmetrical sector. As in its name, the symmetrical sector has a symmetrical beam. So unlike a traditional sector, the vertical and horizontal RF pattern is symmetrical. So for instance, if it's a 30-degree wide sector, then its vertical beam is 30 degrees wide as well. Here's a little animation to show you the unique beam pattern that comes out of our horn antennas. And you can see again in this simulation that the elevation and the azimuth cut are the same. And you can see that the horn itself, or the beam that comes out, is conical shaped rather than a flat pancake shaped like a traditional sector. One of the big benefits of a symmetrical sector is the fact that it has practically zero dead zone or null zone. For you that have used traditional sectors, you know that sometimes being close into the tower, you get spotty coverage or not good coverage, and typically the signal is not very good because you're connecting with one of the kind of side lobes, right? Not the main beam where most of the energy and the best signal is coming from on a traditional sector. On a symmetrical horn antenna, because the vertical beam is so wide and it is all part of the main beam, you get very good coverage close into the sector. And usually down tilt is not needed like a traditional sector, where sometimes you have to kind of, split the signal as far as adjusting down to tilt to kind of get the coverage where you want it to go and still trying to pick up some of those close in clients. One of the other benefits is that a horn antenna has a very constant frequency beam. So if you look at this simulation, you'll see that across the spectrum, the beam pattern doesn't change much, unlike a traditional sector does. Here we can see the comparison between a traditional sector. So you can see that the main beam gets wider and narrower as we go through the different frequencies. And you could also see that the kind of side lobes, so to speak, the top and bottom, they change dramatically based on frequency. This is usually pretty bad because when you deploy your access point or you deploy a new sector for the first time, you get all your customers connected and things are going good. And then at some point in time, you have interference, so you have to change channels. What's unfortunate about traditional sectors is that as you change channels, especially if you go from the upper to the lower band, the beam pattern changes greatly, and customers that used to have good connections may not have them later, and people often wonder why. If you look at our symmetrical sector on the right, you can see that the beam pattern is the same throughout the spectrum, so as you change channels, you don't lose customers like you would on a traditional sector antenna. Another thing is that We also have balanced gain throughout the spectrum. So you can see that the gain from 5.3 to 6 gigahertz is pretty much uniform. Not only is it uniform as far as the change in gain across the spectrum, but it's also very uniform in both polarities, which is really, really important. Here's another simulation that shows the side lobes of a sector antenna. If we look at a ubiquity sector on the left, you can see that there's actually a lot of side lobe radiation outside of the 120 degree pattern that it's putting out, but you also get a lot of back radiation. If we compare that to a 30-degree horn antenna, you can see that the beam only goes out in the direction that you want with very little side lobes and very little back radiation out the back of the antenna. Great noise immunity. Again, in comparison, here's another sector. This is one of the newer AC sectors that's in 45 degrees. This is a much better comparison to our 30 degree because, again, the beam width is pretty close. And this one you can see, again, there's huge radiation going out as side lobes. There's leakage to the back. But the other thing that you'll notice is that the beam itself is kind of warped, right? So it's not really balanced, where horn antennas are extremely balanced, and again, both vertical and horizontal. The antennas that we sell are offered in many different antenna patterns. So we have everything from a 30 degree all the way up to a 90 degree, and here you can see the different antenna patterns, again, for the different horn antennas that we offer. There's some great benefits to having this type of scalability with the antennas that we offer. It actually, for the first time, allows you to build a network and design it based on where your customers actually are. So you're not stuck with a kind of cookie cutter, 120 degree, 90 degree, or 45. You have a great ability to, again, focus your signal in the areas where your customers are. So let's talk about some of the differences between symmetrical and traditional antennas. So if we look at symmetrical sectors, we can see that it's a very narrow and dense sector. It's also made for moderate distance, which is something really important and we'll talk about. They work really great in hills and mountainous areas, again, because of the null zone or non-existent null zone. You're able to mount these things really high and still get good coverage close into the tower without using down tilt. Also, it's great support for close-in customers. Again, you get uniform signals close to the tower and far away from the tower as long as you're within the operating distance. It's also great if you have space limitations. The antennas are obviously very compact compared to traditional sectors, and when needing to increase client density on a tower, it's a lot easier to put 3 horn antennas in the same spot as a single traditional sector antenna. Along with its space limitations or its compact design, you also get much lower wind load issues, right? So again, overall, from a deployment standpoint, sector antennas bring a lot more physical benefits too, not just the customer connections. If we look at the traditional sector, right, we get coverage for very wide areas. It's much larger beam widths. They're done for, again, very long distances compared to the moderate distances. They're best for flat areas where you don't have too much topography and trying to pick up close-in clients, far out clients. One of the things about a traditional sector is you have to have enough tower space. So if you have limitations on the tower, maybe a traditional sector wouldn't be good. And basically, there's no load limitation on the site. If you don't really have to worry about loading on a tower, then a traditional sector might be good. Here again is some more talk about the unique scalability, right? So again, how you can design your tower. If we look at the gain output from our antennas, you can see that the highest gain is obviously the most narrower beam, and our gain is roughly about 18.5 dB on a 30-degree horn, and roughly about 10 dB on a 90-degree horn. Now, distance is the big thing when it comes to these horn antennas, and what's mostly not really understood. When using these antennas, you have to think of it in a different way. It's not a apples to apple, dB to dB type range performance between a symmetrical sector. Obviously, because energy is being transmitted more on the vertical than a traditional sector, the total output is reduced as far as range. Typical range of a 30-degree sector, which is our highest gain, and you get the most distance, is somewhere in the range of 5 to 6 miles from the tower. Of course, this is dependent on noise and what kind of CPE you're using, but typical range is about 5 to 6 miles maximum, and then it starts going down from there as you go wider and wider with the beam. So just to give you an idea on how compact they are, if you haven't really seen them, this is some pictures from a beta site that we did here in Texas, and you can see on a normal pipe upright where you would have just one standard sector, we can fit 3 horn antennas, and basically these are 3 30-degree horns covering a 90-degree area. The other benefit to something like this is the density of customers. Traditionally, a single sector would cover 90 degrees, and we all know that we get probably about 30, maybe 40 customers to APs, to one AP, depending on the types of services that you're offering or the bandwidth that you're offering. Here you can see by deploying these, covering the same 90 degrees, you get about three times the capacity, right? So you get a lot. Show you again how compact they are. Again, they really are about a quarter of the size. It really depends on what sector you're comparing it to, but usually it's between 3 to 4 horn antennas for one traditional sector. Again, it depends on what the physical size are, and not all sectors are the same. So one of the other benefits is, again, these sectors are very robust and extremely durable. We use nothing but high-quality products or materials on everything. The horn antenna itself is made out of die-cast aluminum. We use UV-rated polypropylene and ABS plastic. All our mounting hardware, again, is either stainless steel or stamped aluminum. So the product is made really, really well. So it's a really sturdy product. The unique thing, another unique thing about the horn antennas, again, is our Twistport technology, right? By incorporating a Twistport on here and making a waveguide type element, it makes it really easy to install and upgrade your radios. Again, there's no little pigtails to try and seal and screw on and deal with. So it really reduces the amount of work that's needed in order to install radios and upgrade them, and also to maintain them. So here's just a little bit more detail into the Twistport itself. As you can see, there's a locking mechanism. The outer ring is actually spring-loaded. There is a small set screw that you can use to lock the ring, but really it's not necessary. That little screw is there just as an added security feature for yourself if you feel like using it to ensure that the locking ring doesn't move, but it won't move on its own, so it's not really necessary. So with our antennas, we market them as virtually no loss, and this is practically true. If we're dealing with our Simper radio, where our radio transmits or is built into the actual antenna element, there is no loss because we have no pigtails and no connectors. These horn antennas are also used with Twistport adapters. Those adapters actually have physical connectors, and they have to in order to incorporate the use of third-party radios. All the pigtails that are built in the connectors are really high grade, really well tuned, and the loss is actually much lower than you would get with a traditional sector and these external pigtails that are used to connect the radio to the actual antennas itself. So again, there's virtually no loss in the interface between radio and antenna. So if we look at, outdoor wireless equipment, there's usually 3 units involved. You have a radio, you have the connection interface, usually a pigtail of some sort, and then you have the antenna. Here again is a better representation of that. So how we change things by creating our twist ports and our connectorless radio systems. You can see here again where you have a traditional antenna, you have some pigtails that go back to a radio, and we are able to remove those things. We remove the pigtails, the input connector, and the cables. And here we go. So here you can see the actual PCB board that has the waveguide feeding element built into it, and this is how we get 0 loss on the output side. So again, just to kind of go over the differences here, if we look at traditional radio systems and ours, you can see that the number of components that are usually required to make a radio system is reduced from 18 components down to 12. These things are also important not only for the fact that it reduces your output loss, but it also removes the largest failure mode that are involved with most radio systems. Usually, not only does the pigtail potentially fail or it can get kinked or something can happen to it, but water ingress into those connections are very difficult to maintain. Our antennas support a very wide range of platforms out there. So we support, of course, our Simper radio, which is the connectorless radio. We support Ubiquiti radios, Microtech radios, and Cambian radios as well with our Twistport adapters. So with our Twistport adapters, we make connectorized radios, again, compatible with our patent-pending Twistport technology. So it's quite simple how it works. You take a connectorized radio, you slide it into it, and it locks in place, and then it easily slides in and out. So again, from first install to upgrades and maintenance, it's very, very simple to use. So for Ubiquiti, the current adapters we have are Rocket adapters for the AC Lite, the regular Rocket M5, the Rocket AC PTP and PTMP is actually arriving shortly. And then later this year, we'll actually have a Twistport adapter for the Rocket AC Prism, the newest radio from Ubiquiti. Here again, we have the Twistport adapter for the Cambian EPM P1000. So this adapter fits the regular synced AP radios as well as the connectorized CPE radio and the new light AP radio, which is pretty much identical to the regular EPM P1000, except it's more of a plastic enclosure. So it's not the same building material, but the form factor is the same. So this one adapter would work for all 3 of those different radios. The Twistport adapters from Microtech support a wide range of boards. pretty much the rule of thumb is if it fits that standard small form factor board that they make, that the, like 911, 912, 921 boards, the older 711 boards, and even the connectorized, the 411 boards with mini PCI slots for connectorized mini PCI radio modules work as well. All our Twistport adapters come in shielded and unshielded versions. The only ones that don't come in shielded are the ones for the EPM P1000, and the newest Prism radios won't have it because the manufacturers actually have adequate shielding within the radio itself. So typically the Rocket M5 AC lights and the regular Rocket M5 offer a shielded version because the manufacturer's shielding within the device is not adequate. So we're going to talk about kind of some performance tests that we did, with some legacy type hardware and our hardware. So this is a little test that we did in Slovakia. It's not a very long distance link, but it'll show you the comparison of our radio system to, again, another radio system with some pretty closely matched specifications. So the test that we did is we took a Microtech router board SXTG 5HPND HGR2. There's a lot of letters in there, part numbers. This CPE has roughly a 25-degree beam width. The output gain is the antenna is roughly 16.5 dB, and it's a patched array antenna. What we had on our end is we had the a Twistport adapter for Microtech router board. We used the 912 board that has a mini PCI Express slot on it, and we used our own mini PCI Express radio. So we have an Atheros-based mini PCI Express radio transmitter that has our lossless design that can be incorporated into these Twistport adapters. It was used in conjunction with our 30-degree horn, which has roughly a 18 dB output power. So if we look at the performance test and where it was handled, it was in a very noisy environment. We can easily see 20 other radios on the same site or very nearby, but it was a short link. It was only 0.8 miles, so less than a mile in order to do this test. So when we look at the test, we'll see our radio, when we were running in NV2, we got 97 megs worth of throughput from that radio, and the SXT performed at 84 megabits. When we went out of TDMA mode, out of NV2, and into regular 802.11 mode, we were getting 89 megs over the link, and the SXT was roughly about 85 megs. So the thing to really note here is not just the speed, but it's the stability of the link and how these chains perform. So here we're looking at our radio system running in NV2. And if we look at the throughput, you can see it's pretty rock solid with not many peaks and valleys, right? It's pretty much just 100, close to 100 meg sustained. The thing, if we look at the signal, which is really important here at the bottom, you can see that chain 0 and chain 1 are pretty much perfectly matched, which is very important when you're dealing with a MIMO radio system. Because the beam pattern that comes out from our antennas are not only symmetrical in size, but the way they overlay, they overlap practically perfectly. No matter where you are in the main beam, you're going to get equal vertical and horizontal, or chain 1, chain 0 signal strengths. It's like plus or minus maybe 1 dB. So it's very, very good performance. If we look at the actual SXT on the same link, you can see that the link is fairly stable, but it's not as flat when it comes to throughput. There are some fluctuations there. But if you look at the chain 0 and chain 1 signal strengths, you see roughly about a 5 dB difference between chain 0 and chain 1. When it's unbalanced like this, it's hard to maintain consistent speeds, consistent latency. This is operating in non-TDMA mode. Again, this is our radio module. So here you can see, since TDMA is not being used, noise is a little bit more of an influence, and you can see that the throughput is, again, a little bit more unstable than it previously was, but you can still see that the chain 0 and chain 1 gain are still highly uniform. If we look at the SXT, again, the throughput was a little bit lower, and still chain 0, chain 1 gain difference is roughly about 5 dB. So here's some customer feedback. So we had a install by a company called AU Wireless, and this is their quote: "The Twistport performs significantly better than the Ubiquiti AC sector. No lobes, great SNR, and good vertical performance." Here's another company basically saying how well it worked for the close-in customers compared to a traditional sector. They didn't even have to down tilt it, and the tower is 140 feet above, where the customers were. Here's another customer from Albania. Again, the signal and throughput improvement is significant. Performance of the symmetrical sector antennas from RF elements is excellent. So again, the RF performance of these antennas really are good. Again, there's no doubt that there's a range limitation compared to traditional sectors, but if you operate these antennas within their operating range, and really the only range difference is distance, these things perform extremely well. There's great noise isolation. The beam pattern is pretty sharp. As you get to the end of the beam, you'll notice the moment you step outside of its beam pattern, because gain and signal will drop off sharply outside the beam. So they are very, very precisely made, and they operate in a precise manner. So here we have our own forum as well. So you can join our community at rfelabs.com. Oh, sorry, my slides are getting away from me. Stand by. Here we go. Caught up now. Sorry about that. So here are some frequently asked questions, and I'll be answering y'all's questions. If you have some, just please feel free to start typing them into the app right now, and we'll get to them one at a time at the end of this presentation. But here are some frequently asked questions. So again, the number one question is, what is the expected range of a symmetrical sector antenna? Again, the highest gain sector we have is our 30 degree. And again, typical range is 5 to 6 miles. We have some customers reporting pretty decent signals at 7 miles, but I would say that that's pushing it. That's probably in a great environment. Again, a typical setup, just to give you some sort of comparison, is if you're using a Rocket M5 type device with one of our 30 degree horns, and you're using some equivalent, let's say like NanoBridge 5G 25. That's where you can see, again, about 5 to 6 miles, and you should see somewhere in the low neg 60. So at 5 to 6 miles, you'll see anywhere from a neg 61 to a neg 65, and then of course it starts dropping off from there. So that's pretty much the good benchmark as far as distance is concerned. Another question we get is, again, the frequency range of the Twistport antenna. So there's a lot of kind of I guess not misinformation, but some misunderstanding about our products, right? So the horn antenna itself, right, just the metal horn that you've seen, has a frequency range of the whole 5 gigs. So it goes from basically 5.1 all the way up to 5.9 gigahertz with flat gain across the spectrum. The thing that changes that is actually our Twistport adapter. That's where the difference is. So our Twistport adapters have a range of 5.4 to 5.9 gigahertz. So operating below 5.4 gigahertz, you start seeing a change in performance. The change really isn't in gain, but it's more in VSWR, right? So we have some customers giving us feedback that they've been in the high 5.2 or 5.3 gig range, and the antennas have been working fine for them. Again, the way they're tuned, it's really 5.4 to 5.9. But we're currently working on our next generation Twistport adapters, which will support the whole 5.1 to 5.9. So the next question is, and I kind of answered it, but I'll go into it a little bit more, is what's the performance of the sector below 5.4? So again, the gain drops maybe about 1 or 1.5 dB, 2 dB max from the spec gain below 5.4. But really what happens is VSWR starts going up, right? So it's more of a VSWR question than it is about gain performance. Another question is how close can these antennas be mounted to each other, right? So they can be mounted pretty close. Now, channel reuse is not something that we say can happen. But if you're using different channels on all the sectors, then you can mount these things fairly close to each other, about 1.5 feet maximum, maybe a foot. So basically, if you take the distance of or the rocket that's mounted to it, or the EPM radio, basically right below that you can mount your second antenna, so it actually puts the horns at roughly about 1.5 feet apart or something like that. Another question we've been getting is, is there or will there be a connectorized version of the Twistport adapter for other units, right? So the answer is yes, right? We're working on that right now. There are a lot of connectorized radios that are out there that we're just unable to create the Twistport adapter as you know it, right? For obviously we can't take a Cambian EPM P450 radio and make it click into this little device and twist it on. So we are working on a connectorized version for the 5 gig that will allow you to use really any radio platform out there that's 5 gig that has end connectors on it or something like that. We'll be able to use with a Twistport adapter. Okay, so you can find a lot of information on our website or on our social media sites. So here we have listed our YouTube channel, a lot of great videos. I suggest you guys go and check it out. Obviously, a lot of information is released on Facebook as well, Google+, LinkedIn, and Twitter. So these are some great places that you can go to get up-to-date information. Share with us your thoughts. We're really interested to know what people want and what they're interested in, and how we can help. So with that, we come to the end of the webinar, and at this point I'm going to start looking at some of these questions, and if you give me a second, I'll start answering your questions, and if you haven't posted anything yet, please do, because I'll answer them. So give me 1 second here. Okay, so we have a question here about nobody ever wants to talk about the range. What's the maximum recommended distance of a 30-degree horn? So again, like we said, the max range for our 30-degree horn is 5 to 6 miles. So that's basically the answer for that. We also want everybody to know that we're not really saying that these horn antennas are the only antennas you should use. They're just another tool, right? So if you have a deployment where you don't need 360-degree coverage, or where you're on a mountainside and you have a little valley where 30 or 40 degrees of beam is what you need, these horn antennas are perfect for that. If you have to go a much longer distance, then you have to use traditional sectors along with these horn antennas. They're really being used in many interesting ways by customers. A lot of them are actually using our horns to augment their business and offer different services. So, they use a traditional sector to get that long reach that they need to really cover an area, and then they use 40 or 60-degree horns to kind of cover in the near-range clients and offer them higher data packages, right, with higher throughput, because they can get really good coverage on the close-in clients and stuff like that. So I hope that answers your question about the distance. Let's see here. Okay, so there's a question here about point-to-point. So we actually have a new product that is arriving next week. It just shipped. So these horn antennas with Twistport technology are for point-to-multipoint. We have had a few customers use our 30-degree horn for point-to-points, so that's definitely possible. But we have our new Ultra Dish 380, which is basically a parabolic dish antenna. It's 24 dB, and it can use any of these Twistport adapters. So with our Ultra Dish, you're able to use either a Cambian EPM P with an Ultra Dish as a substitute for like a Force 110 type solution, or you can use it with a Rocket or Microtech for point-to-point. So that's a totally different product, and it's coming to market soon, so you should get with your Streakwave reps and ask them about that. Okay, so what's the expected range of a 90-degree symmetrical sector with a Rocket M5? So the 90-degree sector, again, is our lowest gain performance, roughly about 10 dB. The range for that is extremely low, right? So it would be between 1 to 2 miles is the max range that you'll get with it. People who need 90 degrees of coverage and longer distance are building it out with 3 30-degree sectors, basically, to get 90 degrees of coverage. But the single 90-degree horn will get you 1 to 2 miles, maybe a little bit more. I have a question here about 900 megahertz, if there's any plan for that. So probably not. We are looking at 2.4 gigahertz. But for 900, I don't think that the horn antenna would be right for that. One of the big things is, you know, the size of the antenna, you know, is kind of linear to its frequency, right? So if we look at the hole of the Twistport adapter, it's roughly about 1.5 inches in diameter, right? So a 2.4 gigahertz would actually be about a 3-inch hole for the Twistport adapter, and you would double the size of the end portion of it, right? So our 30-degree horn is roughly about 6 inches. So a 2.4 gigahertz would have like a 3-inch hole where the Twistport adapter goes, and about a 12-inch, you know, diameter at the end of the horn. You go to 900 megahertz, you're almost doubling that, right? So pretty sure that 900 megahertz won't be, but if we find a really cool way of doing it, I can assure you that that'll happen. So, okay, I have another question here. Okay, so another question is, can these be used back-to-back on the same polar mass? So absolutely. Again, we kind of request that you have some distance between these things. You know, near field radiation is still an issue. These things don't have, they practically have zero, you know, back lobes, right? So the front to back is really good on these, but it's still not isolated enough for you to reuse channels. So as long as you're using different channels, yeah, definitely they could be very close together. Question about 2.4 gigahertz symmetrical antennas. I think I answered that, so we're definitely looking into it. So stand by, watch our, stay on Facebook, join us on Facebook, or follow us on Twitter, and you know, you'll know as soon as we announce it. We will definitely be going to WISP America, so please feel free to come visit our booth in Streakwave at WISP America in March. Another question is, are we going to have, again, 2.4 or 3.65? So again, yes to the 2.4, and yes, we're looking at 3.65. 3.65 is probably a better reality for us because, again, it's the size of the horn is you know, better matched to what we would like to see. So we're definitely looking at the 3.5 to 3.65 range for these horn antennas. So, you know, keep tracking us and stay on Facebook, and we'll let you know as that happens. Let's see here. Okay, so again, another question is coming up, or a follow-up question to using the symmetrical antennas that in a lobe area of the same frequency of a traditional sector. So that's kind of hard to answer. So I would say that if you're within the lobe of the transmitting antenna and you want to be on the same one, that it probably wouldn't work, because again, the near field radiation that comes off of these things will probably conflict with each other. So again, channel reuse is not something that we can say we can use. Question about the ultra dish, what will the range be? Again, the ultra dish will work very similar to a traditional dish antenna, so there's not too much of a difference there. So if you did a calculation on a 24 dB dish antenna, then that's kind of the distance you'll see. The only big difference with our ultra dish, because it's still waveguide fed and the side lobes are suppressed, you will get better noise immunity. So because of the noise isolation, you'll get better overall link budget, and therefore you should see better performance. So I don't really have like a point-to-point range to give you, but you should see really good performance on that. So somebody's asking if we're looking at doing a feed horn or something for Telerad CPE 7000s. Again, I don't have an answer for you on that. We are looking at many different vendor radios. Our first way of dealing with a lot of these vendor radios are coming up with the connectorized Twistport adapter, which will allow you to use it with any vendor you want, as long as it's in the 5 gig range. Question about cold specs and cold environments. So I don't have the hard numbers for you, but these things were made and designed in Slovakia, which is really cold. We have customers using them in Alaska. It is a new product, right? So it's only been out for 4 months or something like that. So we don't have any really long-term data points for you, but we have them in Siberia, we have them in Alaska, we have them in very cold environments right now, and so far no negative feedback. Again, if you haven't seen one of these antennas, I suggest you try one out. When you see how it's built, you'll know that it does very well. We're coming towards the end here, and if you guys keep feeding questions, I'll keep taking them. So we're getting close to the list here, the end of the list. Let's see here. So yeah, question about having any wisps test them. You could always email us. We're interested. So if you email RF Elements direct at sales@rfelements.com, we can have conversations. We've had many beta tests already, and they're looking good. We're always interested in getting some really detailed feedback from customers. So if you're interested in trying these out, just go ahead and send us an email and we can talk about it. Being asked, the slides will be sent out. So this webinar is being recorded, so it will be on Streakwave's YouTube channel, so you guys will be able to see it offline later. Let's see here. I believe that is it here for questions. So again, everybody, thank you for joining. I appreciate you all taking the time to listen to what we have to offer. Again, from RF Elements, we're very interested in hearing from you and answering any questions that you have. Your Streakwave reps are very well informed on these antennas, so feel free to email them as well. And if you have any questions, again, let us know. And thank you for your time, and hopefully we'll see you at our next webinar. Bye.